Well, we're got a couple folks in here and we're grabbing some of the snacks. I know we've got a lot of folks online.
So if anyone is watching remotely from within the council house, you're welcome to come down to classroom 104.
Yeah. Let's see, Mike is saying the audio is choppy. How are other people hearing us? I know we've been talking with Andre.
Yeah, I'm getting you loud and clear over here.
Okay. Mike.
Jim, it's Bo. I get you loud and clear, but some of the other stuff I'm not getting.
I don't know if we've said much else. Can you hear me okay, Bob?
Yep,
No.
I have you now. That sounds good.
So everyone, welcome to our first Friday Talk of the Year. This is kindly organized for our department by the INCOSE RAMS, which is our student INCOSE group. And I'm going to turn it over to Andre.
Hi, good day. So I'd like to give a big welcome to everyone joining us for today's Professor Pitch event. This event is brought to you by the INCOSE RAMS Student Division at CSU. INCOSE is the International Council on Systems Engineering. So I'll take you through our agenda.
Introduce yourself a little bit.
Oh, sorry, I'm Andre Dixon. I'm a master's student at CSU. I'm in my second year now. So our agenda for today is we will be taking you through some INCOSE events across the world, and we'll take you through events that the Student Division will be hosting at CSU. And then we'll take you into the main event, which was our professor pitches. We have 5 professors who will be giving pitches today. After that, we'll just walk through some discussion points. So our INCOSE events that are coming up, the Student Division is part of or sponsored by the Colorado Front Range chapter. So they'll be having a debrief session on the Western States Regional Conference. So that will take place next Thursday, virtually. INCOSE is going to have one of their regular webinars on the meaning and purpose and value of systems engineering. That's on October 1st. And you can see what it's going to be about: 5 recommendations to help systems engineering community restore sense of creativity and excitement to the discipline. Then we have one of the 2 major INCOSE events that will be taking place in 2026. So we have the International Workshop. This is a hybrid event in end of January into February. It'll be hosted in California, Torrance, California. Then in June 2026, we have the INCOSE International Symposium, and that will take place in Japan. That's also a hybrid event. And submissions should be due for that in January 2026. And if you go to the INCOSE events page, you'll find a lot more events that are taking place with INCOSE. So for the student division, our upcoming events at CSU for the next 3 months in October, we will have our own recap of the Western States Regional Conference. In November, we're going to look at the nuclear industry. So we'll have 2 events. One is a presentation on systems engineering in the nuclear industry. And then we're going to have an on-site tour of a nuclear facility in Denver. And in December, we're going to invite you, the students, to TED Talk presentation. So you will be giving presentations to the rest of the student body. So I'm going to now move on to what we're all here for, the professor pitches. So each professor is going to take 5-7 minutes to present and take questions from you guys. So we're going to start off with Dr. Sharudi. So if Dr. Sharudi is ready, he can take over the sharing.
Let me know, see, hear me and everything. Is good? Okay, great.
Yeah.
Well, I came in ready for a 2-hour presentation, so I'm going to do my best to do this at 7 minutes, which is great. Nothing like urgency. So I'm a systems fellow at Woodward here in Fort Collins, and I've worked at a lot of different divisions at Woodward. And then since 2008, I became involved with CSU, and I'm one of the founders of the CSU program. Recently, I got my, last year, I got my ESEP, which was really cool. So I have a few slides and I'm going to go quickly since we don't have time. I wanted to talk a bit about systems thinking and why it's important. And how do we classically approach difficult problems? If you look at how our universities are divided, businesses are divided, high school is divided into all these different subject matters, then why do we do this? And the answer is that our education culture and business rewards linear compartmentalized thinking. And I'll be a bit more clear what I mean by that. But some examples of simple cause and effect or linear compartmentalized thinking are here. For example, if you're fighting the homelessness problem, if you say just give a free home to every homeless and $30,000 cash per year, and if you expect that the homelessness problem will go away that way, then that means you're very linear and simple cause and effect thinking. Okay, there will be a lot of consequences to doing that. And we now know that linear compartmentalized thinking is actually causing a lot of the issues that we face. So we actually cause problems, not really solve them with this kind of thinking. A simple example is when you have a heart palpitation problem and naturally you go to a heart doctor and they want to do an operation on you. This is actually my personal story. I had a tachycardia problem and they were suggesting $100,000 invasive surgery to zap the nerves in my heart. Then I discovered that it was actually caused by caffeine. And so just by cutting out caffeine, I managed to totally avoid that surgery. And then I later met people who had that surgery and they had a lot of side effects. So we like to put people inside a very limited, narrow responsibility, and they just should shut up and do their job. And they make actions without being aware, without having the vision of the bigger problem. And so they cause an action, it seems to work, but then it comes back with feedback and then hits them on the head. It's the same as this old Sufi story of the elephant and the blind man. It's not possible to understand the elephant if you don't know the elephant already and you just touch the different parts. Like these guys, one of them thinks it's a trunk, one of them thinks it's a spear, and so on. This is a fishbone diagram of a cigarette consumption. You may say, well, this is a good start to understand the cause and effect on what impacts the daily consumption of cigarettes. But then what's wrong with this is that linear thinking causes us to think that these factors may not be interrelated and there may not be feedback. So actually daily consumption feeds back to some of these other factors. So it's not quite as simple as we would like to make things. So this is, for example, a systems thinking way of dealing with it. It's more circular. You understand the different loop structures that give rise to those effects. This is another example of linear compartmentalist thinking. It can be bad for your health. These two guys are obviously not thinking they're part of the same system or they will even be impacted by it, let alone thinking that they should help these four other guys. But it will come back and bite them. There's a couple of videos we don't have time for, but I'll share this and you can see, the way we think impacts the way we look at problems and the way we look at problems impacts the way what we think about them. So those things are very interconnected. So the bad way to think or bad philosophy impacts how we see things. For example, look at the lower picture. From one perspective, everything seems fine. From the other perspective, it's a person who's sad and there's a problem. Same as here, the way we look is important. Here, there's actually a picture of two people on the left, a young and an older. And then here, this mountain range actually has a lot more hidden information in it. Which is a more useful view of a tree? Well, a lot of people tell you systems thinking is about out of the box and like a helicopter view and kind of like a high level view, but that's not true. Systems thinking is about everything. It's about the details and the inward looking, outward looking, and then how those views are interrelated. Looking at the bat and the moth, if you look at them in isolation, you do not understand that they actually impact each other other than the eating prey-predator relationship. For example, some of the moths have developed anti-jamming sonar. So when the bat comes to eat them, they do this trick and the bat goes into a wrong direction and tries to catch it out of somewhere else in the air, where the moth isn't, which is pretty cool. So just two more slides. How are systems thinking and systems engineering related? Well, systems thinking is about a philosophy and rigorous method to understand and find leverage on real world problems. Systems engineering about finding a solution to them. Okay, so there are two sides of the same coin, but they're not the same. And they need each other, but they're not the same. And if you look at it, on the part that's on the left, which is the philosophy, it is accessible to every discipline. You do not need to be a system engineer to be a systems thinker, and it's directly accessible. And if you want to learn more about that, there is a book coming out. You can already order this, and it's exactly trying to make systems thinking accessible to all the disciplines. And it's written by me, a colleague, Steve Conrad is another professor here, and several students. Thank you. Think from the room now.
Does anyone have any questions for Dr. Shirley?
Yeah, anybody online, go ahead and jump in. See something you want to ask about? When are the courses offered? Anything like that? What else are you working on?
This is what happens when I go really fast over my slides.
Everybody's overwhelmed then.
Well, If nothing, I hope that it was a good wake up. Go ahead.
Anybody else? All right, Andre, who's next?
So Dr. Mazoff is next.
Hi, everyone. Thanks, Cameron, for that. Can you all hear me in the classroom there? Just checking.
Yes, very well, thank you.
Okay, good. I don't have any slides. Actually have lots of slides, but I'm not going to present them here to you today. First, thanks for giving me a quick opportunity. I don't see this as a pitch. I'm not trying to sell you on anything. I'm just my goal here is just to inform you about a couple courses that that you might be interested in, and if you are, great, and if not, great. So it all works super. But I'm going to and I'll try to do this pretty quickly, which I think I should be able to. So I'm Professor Greg Marzoff. Many of you are in my class now. I recognize many of your names, but I'm a retired Air Force colonel turned doctor, and I've had a great opportunity to teach. I'll talk about the 501 course, which is the Foundations of Systems Engineering. And what I found is that many of our students, as they go through systems engineering, really don't know what systems engineering is. So the right side of the coin, as Cameron pointed out, there's a bit to that, from a needs analysis to what's concept exploration, what's advanced development, how do we work across a life cycle, considering cost schedules, risk, and a number of other constraints, the differences between effectiveness and suitability aspects, such as reliability and maintainability and so forth. So a lot of this just tends to this life cycle tends to get missed. So we have the 501 course, which is this foundations course, addresses all of that. So if you want to learn something about systems engineering, like how do we go through it, and how do we think about complexity, and how do we deal with it, so that you can apply it into your 695 thesis, or if you're doing a doctorate, you can actually use systems engineering as part of that process, so that when you finish your doctorate, you actually feel like you've applied systems engineering. You get this through a couple projects. We do is highly teams based. So we've generally formed groups of 2, 3, sometimes 4, and we work through a couple projects throughout the life cycle. So you actually get to apply the stuff in the course onto a system of your choice. And it's anywhere between 20, 30 pages, each one of these projects. Of course, there's some homework and there's some discussion stuff, but general feedback's pretty good. One of the nice things is if you complete this course, it has earned INCOSE academic equivalency. So if you take the course and you earn a B+ or greater, then hey, voila, I submit your name to INCOSE, and then you can apply for one of the certifications. So it's really nice, and Jim Adams helps out quite a bit with this course. He helps set it up, but it is the foundations course, and I would, it's heavily attended. I've got almost 90 students this semester in the course, but I'm glad to have more, and just know you're welcome. If this is something that you're interested in, then I'd be happy to talk to you more about it, or you can, there's other students there that are taking the course, and just most students tend to take this course. It's pretty well attended. The other course I'll just mention, and that's this course, it's a test engineering class. It's a 603 course. It's SISI 603, Introduction to Systems Test and Evaluation. And the idea here is, the problem we have with complexity is we have a lot of unknowns, and unknowns means uncertainty. And what tends to be lacking a bit is how do we deal with the uncertainties when systems engineering is attempting to not just choose a path forward for the system, but the correct path. So we can see there's lots of paths, but what is the correct path? So this course, Introduction to Systems Engineering, is focused on how do we deal with those uncertainties across a number of different acquisition life cycles. So we have some that are highly prototype driven, some that are heavily model driven, some are data driven, some are empirically driven, and so forth. So it's so we look at these different life cycles and acquisition life cycles, and then we figure out, how does test and evaluation inform across those life cycles? And then we actually do a test plan. You actually get to do test plan, think it out, and how do we deal with uncertainties and variability in the data and so forth. Eventually ended up with a test and eval master plan where you'll actually do a temp that basically guides the program from a test or V&V perspective all the way from inception to the end. In fact, the temp is generally one of the early first documents that gets formed. So you might think, well, no, it's something we do later. Well, no, it's actually something that you do right pretty close on the front end. So this is a course that I think is really useful. It's not an easy course. It's a lot of reading. I designed this course, so I'm a prior fighter pilot. I'm seeing the Thunderbirds flying around out here, bringing back old memories. I've got about 3,000 hours in the F-16, and not a red, white, and blue one. Those are gutted jets, but real ones that you actually go fight in, and a lot more fun to fight than to do loops of music. But in any case, they're having fun. It's all good. I'm enjoying watching them, and we'll see how it goes. But in any case, it's not a super easy course, but the general feedback is students are really happy that they take it, and they find quite a bit of use in the course. So that's it. I'm at 5.5 minutes roughly. So let me stop there. I'll take any questions you might have, but thanks for being here. Thanks for letting me just give you a little info about these two courses. What might I answer for you?
Yeah, go ahead and open it up. You folks here in the room, lots of folks online, jump in. 501, 603, and anything else airplane related.
Yeah, exactly. Okay, well, where you can find. Oh, go ahead. You got a question?
All right, so I noticed that you have a big Air Force background. So I'm working for the Air Force right now. So this test engineering course, you think it'd be really value added for me doing help me with my career in the Air Force as an engineer doing system safety.
Jim or somebody, that was very garbled for me. Could somebody, if you heard it, could you repeat it? I couldn't hear it.
So he's in the Air Force. He wants to know if the test engineering course is going to help him in his career.
He wants to know something about test engineering. What was exactly the top context?
I was wondering, all right, so I'm in, I know it's garbled, I'm sorry. I currently work for the Air Force, and I've done some testing. But I was wondering how much value added taking your test engineering course would aid in me performing my duties as a system safety.
Okay. Yeah, so that's a great question. Here's what, so I'm not, you say you're a test engineer. I would want to talk with you a little bit more to figure out exactly what you're doing in the test engineering field. This course generally starts with acquisition pipelines and then looks at failure modes and how do we go about thinking about test and eval from an eliminating failure perspective, both across components, but largely from systems perspectives. So it's probably would be quite useful to you if you're just doing kind of like ground-based test engineering. You would probably really like this course because I think it would open the horizons a bit for you, take the blinders off a bit, and maybe provide a little broader perspective on how we use T&E from a larger systems perspective.
Yes, sir. Thank you.
You're welcome. Any others?
Yeah, how does the 6th generation fighters compare between China and the US designs?
I don't know, Cameron. I was I commanded an aggressor squadron. The stuff you see in Maverick and all this. That's what I did. I was flying these, commanded an entire squadron of this. And back in around 2015, 16, which seems like eons ago, there was still quite a comparative advantage, on the American side. But I have to tell you, based on what I'm seeing, I don't think that gap exists largely anymore. So probably much more equal, but I can't tell you for sure because I don't know, but I always, of course we used to know everything about enemy fighters, and we had exploitation, and there was a lot of work done at high levels of government to see that we knew exactly what was going on. So I don't know any of that anymore. I'm just a dumb civilian with my jaw hanging down. Hey, there goes a really fast airplane across the sky. So that's all I can say. Sorry, I can't help you.
Well, that was already more than I knew. Thank you.
Yeah. Okay. All right. I'm about 10 minutes. Anything else? All right. Jim, I'm going to turn it back over to you then.
Yeah, that's Andre.
Okay, thanks very much, Dr.
Okay,
Mazov.
Andre. Yep.
So now we have Dr. Butyarov.
Hello, let me just pull up some slides, had a few put together. So I'm gonna go through them a little quickly as well. Just a little bit about myself. I actually went through the doctoral program here at CSU, graduated back in 2023. And then I started instructing some graduate courses, so focusing more on the program management side and the context of engineering management. A little bit about my background. I started out on more the space side of the aerospace industry. So worked at United Launch Alliance, worked on the second stage for the Space Launch System vehicle. So writing requirements, a lot of requirements management, traceability, that type of stuff. Wanted to transition more into the management side. So working at Sierra Nevada as a program manager, so supporting a lot of contracts ranging from Air Force to Navy. Wanted to talk about two courses. So specifically the first one here, ENGR 502, that's our engineering project and program management course. It's offered every fall, the spring of odd years, and then the summer of even years, so twice a year. Basically, the intent of this course is to expand the technical breadth of project management. A lot of engineers, I think they're really good at what they do on the technical side, but just seeing the bigger picture and how engineering projects operate. So we'll take a look at in this course a lot of best practices of project management. So looking at items from the Project Management Institute, the PMI. They have a lot of publications out there that I integrate in this course in addition to the actual textbook. And the goal is this can also set you up to obtain certifications. So the project management professional, the PMP, if you already have some work experience. If you're just a student focused more on the academics right now, there's also the CAPM certification. So just one level below the PMP, but still really demonstrates to employers that you have a solid grasp of project management. So in the actual course, just kind of a breakout here, some of the topics we discuss, the softer skills like leadership and team building. And then we also talk about project management skills specifically, like scope management, scheduling, creating resource charts, so resource management, and ultimately finishing up there with project evaluation. So really touching on earned value management. I think that's a really prevalent methodology used in industry right now. I try to make this course as, let's say, advantageous to you as possible. So not just preparing you for certifications, but then the project assignment category here, that column, you choose a project that maybe you're working on, maybe that you would like to pitch at your organization, maybe that is just an academic project, and you build this project management plan that we increase every week by adding the topics that we discussed. So, you create a scope for it, you create a risk register and so forth. So hopefully you'll be able to get more well-rounded in that project space. Just the textbook here, again, won't really go over it, but the second course I want to pitch is ENGR 580A7. This is a new one I put together and actually ran it for the first time this last summer. It's AI augmented engineering management. It's actually going to be offered the spring of even years and then the summer of odd years. So once a year. And really the intent of this course is to talk about how AI can be used within the management context. I know we have several courses that just talk about AI, maybe AI and systems engineering, but just really seeing how a specific AI algorithms, prompt engineering techniques, and so forth can actually be used again in the engineering management context. I think a lot of engineering managers, right, we hear the term AI, it's a buzzword, we want it now. But I think just understanding more in depth of the actual environment of AI, right, machine learning, what are those algorithms, deep learning, then obviously Gen AI, natural language processing, just defining these terms a little bit more, again, in the context of engineering management. So really building on 502, in 502, we put together that project management plan. Here, we're going to do a similar task, but now we're going to compare output of some Gen AI tools used to put together some engineering artifacts and really evaluate them and see if they're providing value, maybe how we interact with them and so forth. So what I mentioned is the second part of the course, and you can see the first 5 weeks or so is more of the environment piece that I mentioned. So talking about more of these algorithms, the foundations of adopting AI within the organization, ethical considerations, as well as some future trends in the AI engineering management space. Just have the textbook listed here as well, but that's really all I wanted to present, pending any questions from the group here.
Thanks, Dr. Butcherov. So do we have any questions?
I think there'd be quite a few people wanting to jump in on some questions here. Is AI going to take away the program manager's job?
I sure hope not. But that's a great question. We'll definitely touch on that in the course and potential job displacement, or really posturing it as an opportunity where AI literacy is going to become a crucial skill in the workforce, probably now, really, and especially the next few years.
If you have people already with TMI certification, would they benefit then just by joining your second class?
Yeah.
Oh, okay. So that would
they
work.
definitely could, and just in general, I mean, even taking 502 and getting credit for those PDUs, right? The ongoing education for PMI just to maintain certification, that could be an incentive as well.
Great.
All right, I'll give it back to you, Andre. Thank you.
Okay, thank you, Dr. Butcherov. Just adding, so 502 is also one of the foundational courses for the SC program. So that's another incentive to take that course. So we'll hand over to Dr. Gallegos.
You don't get this audio on?
Gotcha.
All right, can you all hear me okay?
Yeah.
Excellent. Slides.
Turn on your camera. You can see.
I think it's on. It was on. That's okay.
Okay.
All right, so hello everyone. I'm Erica Gallegos. I'm an associate professor here in our department.
I put a link to my lab in case you want to learn a little bit more about what some of my students and I are working on. That's what the QR code goes to as well. I don't have a nice slide that introduces me other than just a link to that in my picture.
I'm
So
a link.
you have to come to my class to know more about me. All right, so I put together a couple slides about the two different courses that I thought were exciting and relevant to you all. So the first one is our SYSE 534 Human Systems Integration class. I offer that every spring semester. Basically, that class is looking at how we design, operate, and maintain systems. So thinking from the entire life cycle, from development all the way through maintenance, and even decommissioning systems as well, that predict, evaluate, and respond to actual human behavior. So I think oftentimes as engineers, we think of the perfect fictionalized user that doesn't actually exist and how they might use our systems. And we fail to actually account for real user behavior, whatever that might look like. And so this class is really focused on how do we, throughout the life cycle, whether it's developing a brand new sort of infrastructure or system to deciding whether we need to make revisions to an existing system, and trying to optimize safety, performance, and satisfaction of the human operators so that we can predict when errors might occur, deviations from our expectations occur so that our system can actually handle that and account for that. And so this class really focuses on breaking this, lens of blaming human error for incidences and instead saying, perhaps we should have thought about it as designers and it's really the onus on the engineer. And instead of saying human error caused a problem, it's really design error that caused the problem. So that's what we're really trying to focus on in that class. So how might we do that? You, I'm sure, are asking. This is a breakdown week to week, and it's not maybe the most exciting slide, but I'll try to highlight some of the key parts here. So in this class, we start out, very introductory, thinking about design thinking, what determines success in a system, and really get grounded in what that might look like, again, from the perspective of safety, performance, and satisfaction are really driving these human systems integrations. And then we start to look at understanding the limitations and the capabilities of the human operator, the human users in our system. So opportunity to learn a little bit about psychology and trying to incorporate psychology into our engineering design. So we learned quite a bit about the visual sensory system, auditory, haptics, some other sensory modalities. Then we look into cognition and try to understand how people process and interpret and actuate on information, which leads into decision making. And then we take a step away from the human and we take everything we learned about their capabilities and their limitations and how they process information and look at that into designing kind of those smaller components, so displays and controls of systems. And then, we did, design, we think about creating, and then we switch to evaluation. And so in weeks 10 through 12, we think about how would we conduct, experimentations with human subjects, with human users to understand qualitative, quantitative performances of the system, again, with respect to the humans. And then looking at, specific types of equipment and performance measures we can do. And then we bring all that back together and piece that together with more of those large scale systems, complex systems, looking at human computer interaction and human automation interaction. And look at the design or the interactions again between humans and some of those more complex systems. So that is the human systems integration class that I offer again every spring semester. The other class that I'm really excited about is the engineering data design and visualization, SYSE 541. That is offered every fall semester, and I try to pitch this class as no matter what your skill set is with data, with statistics, or with programming languages, you can benefit from this class. And so, if you're more in this beginner stage, I like to come at this, philosophy as, data and statistics and even programming languages are difficult, they're intimidating. And so we try to break that barrier and make it very approachable. We don't put too much statistics in this class. It's more getting to know data and getting to know how to communicate data to stakeholders and whoever your audience might be. So that's, the beginning. You don't necessarily have to be an expert in this class. We do use R and RStudio. I would say most students do not know how to use R coming into the class. And after the end of the class, I'm not just saying this, but there's definitely some enthusiasm for using R. So gain that excitement. If you're more in the intermediate stage where you think, you already know program languages, you already know visualizations, I would make the case that I could probably point towards several flaws in some of your visualizations. Oftentimes plots, fall short of design. And so we learn ways of how to really streamline what you're trying to communicate to your stakeholders. And then even if you're an expert and you think you know how to program in R, you know how to or use Python, whatever your tool of choice might be, again, open source software advances very quickly. So there's always new packages and libraries that make your life easier. And so there's value in the class from that perspective as well. Again, just showing kind of the breakdown. I try to balance this class between theory and application. So you can see on the left side, I try to go back and forth each week between talking about theoretical constructs of information visualization, not specific to any sort of programming language. So if you absolutely hate R, which I don't know why anyone would ever hate R, you can still get value out of the class. And, after the class is over, repeat what you learned in Python or MATLAB or whatever that might look like. So again, we start the class talking about what makes visualizations good. We go into data wrangling, data handling, so that we understand how to actually structure the data so that we can make value out of it. And then we go back and forth talking about what makes a good visualization, what are the different types of visualizations. We talk about cognitive issues and how people interpret information from your visualization. And then we go into some unique use cases of very specific types of data, so spatial data, text data, interactive visualizations, and then looking at if you are doing more of the inferential statistics, how you might visualize some of your model output in a approachable and meaningful way. So those are the classes. I guess the too long didn't read slide here is human systems integration, spring semester, engineering data design and visualization, fall semester. Both of my classes are accessible and open to absolutely any student. So whatever degree path you're in, they also align with our human systems integration certification. Certificate is what that should say, and also online and in person. So there's no reason not to take the classes. That's it.
Okay.
That wasn't a good closing.
Yeah, and I want to say, I wish I would have had the human systems integration course before I tried an automation project working in space systems a while back. And it was really the development plan that got messed up, right? We were doing partial automation, which meant the operators had to not only do their job, they also had to deal with my automation that was coming alongside. They didn't like it and they shut it off or caused it to fail. And so even the best laid plans, can be shot down because just didn't consider that the folks I was relying on needed some encouragement, needed to be respected as well. So yeah, a lot of great lessons in the course. Does anybody have any questions for Dr. Gayos?
Fair enough. I'm sure everyone's very excited to listen to Dr. Simsky speak, so I will not keep you from his excitement.
All right. Hopefully you can all hear me okay.
Yeah.
All right. Thanks. Appreciate that. So I'm just going to go through the 5 courses. You can see the next semester they're taught. The first one is Intellectual Property and Invention Systems. That's every spring. So it'll be available in spring of 2026 for those of you interested. Real quick overview of this. This is something that gives you an understanding of everything from patents to defensive publications to copyright to trademark, all of those things. You get those in like the 4 or 5 weeks, and then you actually learn how to develop patents of your own, how to build portfolios. I go through everything from biology to chemistry to physics, all the way up to, of course, culminating with systems engineering, how to actually build patent portfolios out of the work that you've done. It really highlights the creativity in each student, et cetera, et cetera. You will learn how to do this, and you will learn how to become like this thing here, a pain in the ass, as you can see. And what you'll do is be able to understand different types of IP, be able to work and write with a patent lawyer to file a patent, know what is and what is not patentable, and then we'll come up with patterns for patenting, ways for you to produce more value out of those, and become familiar with the linkages between the different sciences and engineering. I had the privilege of being part of the 38,000 patents split up when HP split up in 2015, and have about 250 patents myself. And so that's the background for that class. As you can see from the syllabus, you learn all about the different types of intellectual property. Then we go into methods of inventing in each of those fields. And then at the end, I have 3 wonderful guest speakers. Actually, one is a pair of guest speakers, so 4 wonderful guest speakers who worked with me on various types of portfolios, and they cover all of the different areas, from like managing portfolios to actually doing the patenting process to actually understanding software patents, and of course AI patents that Scott Slomowitz and I cover in the last week. So you'll find out a lot about how AI patents are going to go, because we have that track record with software patents. So that's the first class. The second class is also in spring, so coming up soon, and all of my classes are classes that are not required. They are obviously classes that you can take if you've got room in your schedule. So this is Systems Engineering 512 is on sensing, signals, and image processing. And what we do here is we cover what sensors are, talk about the basics of how signals are filtered, normalized, standardized, etc. Then how they connect back to processing, and then how we do elementary signal and image processing. We do some fairly advanced color science. This is I think the only class at CSU with color science in there. Walk through that and actually show the application of color science, to things as far afield as like synesthesia and music and things of that nature. And then we get into analyzing signals and images using classification and hyperspectral imaging. So Erica Gallegos just talked about, Professor Gallegos just talked about, her class leading into human understanding. And of course, color is a very significant input to that. So this would complement that class rather well from that standpoint in terms of how people see color. And again, the odds are pretty good. About 3% of you, which maybe means 1 out of the total people in this room right now, has some type of a color challenge, either red, green, or blue, or more color challenges. The syllabus is fairly straightforward. As you can see, this class has a lot of homework to exercise what you're doing there, but that's basically the course in a nutshell. The next course is in the summer next year, so it's coming back for the summer class, and that is the cybersecurity class, 569, which gives you a general introduction to cybersecurity all across the board. Cyber, of course, is communication. Security is being free from danger or threat. And so what this does is it acknowledges the fact that we used to have separate channels for everything, right? TV, radio, newspaper, all these things were separate, robust channels. If one went down, the others were working. Everything's on the internet now. And so we really can't afford to be frivolous about this, even though some people are. And we'll talk about best practices to make all of that happen. This gives you a good idea of how the course starts off. I give you the overview, basic cybersecurity principles, and then build on that. And of course, the overall objectives are to provide general systems engineers with a grounding in cybersecurity. So on any team you're on, you may be the interface with the cybersecurity expert. You may be the expert if it's a small enough team, but you will be able to take anything that a cybersecurity professional has done and translate that into English for the rest of the people there, and also help with the design. We focus on what is called SecOps, Secure Concept of Operations. Those of you who know ConOps, which is probably most of you, that is meaning you build security in from the ground up along with the overall concept of operations, and we talk about ways to do that. These are all the sections that are in the course. It's a eye chart, but the basic gist of it is after this class, you will be able to sit and accomplish your CISPA certification if you so choose, your basically cybersecurity certification. And many students from this class have done that or taken other more elemental or less time-involved certifications from that. Breaking news, though, this came yesterday. This is the cover of the new book on critical infrastructure cybersecurity. Alexandra Skalko graduated with me as her PhD advisor 3 years ago. This is what happens to students who put their PhD as a starting point for where they're going to go. Really excited by this. This book should be available to the general public probably in about 4 months based on the way supply chains are working right now, but we have the book finalized. It's a big one. It's 470 pages, but talks about everything from biometrics, again, hooking to what Erica talked about in her class, all the way over to water and other infrastructures. Cool stuff. Topical syllabus, we've already kind of gone through, so I think you can kind of see where that class goes. It's a lot of fun. And like with all of my classes, there is a project or more, two projects in a class coming up for you to really show your creativity and shine, in addition to the more, the homeworks and midterms and all of that are based on the slides. So it is fairly self-contained. You will have all you need to become a cybersecurity professional. The next class I'm teaching now, and I teach every fall, and it is 571 Analytics. Real good follow-up to Erica's Systems Engineering 541. I've written books on meta-algorithmics, meta-analytics, and text analytics systems, and all of these are very much applied analytics, building big systems out of that. You might notice a familiar name on here as well. My co-author on this book is Marie Vans, also in our department. And the overview of the course is that you're going to compare and contrast algorithms and processes used for intelligent systems. If you do pick up R sophistication from Erica, which I would definitely recommend, it'll help you in this class. You'll be able to just roll over everything into R. I do walk through the IDE quickly early on in the course, but you're allowed to use whichever IDE software, whatever you want to use for the class. A lot of people use MATLAB, some even Excel, a lot of them Python, etc. A few using Rust now too, which is kind of cool. And I'm pretty agnostic to that because I'm a long-time developer at HP, so you can hand in whatever you want, and I should be able to read it. We talk about applying intelligent learning to empirical data. We talk about AI as a concept, as a plug-in, as a module in the systems that you're building. You will learn about AI and machine learning to augment all of the deep statistics, both empirical statistics and then also parametric and non-parametric statistics. You'll learn all of that. But again, remember that 50% of all the data that's out there has been created in the past 2 years. It's crazy. And people are misapplying deep learning. We talk about, people are counting on AI and it will hallucinate. It'll use energy to the tune you can't imagine. If you type in one prompt into a video generating AI, it's the same amount of energy is being used as leaving a microwave on for an hour. And it's hidden from view, right? And there you are in the powerhouse. It should be something we're talking about. And again, we'll talk about AI being a component in modern data systems. It's not the systems itself. We take a lot of model-based systems engineering approaches to the various patterns for meta-algorithmics and meta-analytics, which allow you to get much better overall system performance, and most importantly, the errors that are made are much more minor. The biggest thing what we worry about with systems is that when a mistake is made, how do you recover from it? Using meta-analytics and meta-algorithmics will allow you to have much less crucial mistakes made in the system. Again, another little eye chart for you just to show how it all works. But as you can see, we learned statistics, machine learning, non-parametric statistics the first third of the course. The middle part of the course would complement the types of things you've learned in Dan Herber's 567 or 667 class, if you're familiar with patterns and model-based approaches. And then we get into a lot of applications from, clustering and classification. 2 fun projects. The first one is a simple one to get you to exercise your software, whichever one you're using, skills. And the last one is a creative one that you get to decide yourself. As with all of my classes, the midterm and finals are take home for a week. Right, I'm not going to sit there monitoring you with an exam. That's just not going to cut it. And then the last one that I'll talk about today is spaceflight biology. This will come again in fall of 2027. It's happening right now. And it's a must for people who are going to be interacting with folks going up into either, lower Earth orbit or out into outer space. We talk about how to actually make it possible to go to Mars. Tremendous amount of work that has to be done there. And again, remember, every single thing that we know of that lives has evolved under gravity, under basically the same gravity they have right now. People who go into space are heroes because they're disappearing from this little thin shell that we've got that has atmosphere. And it's a very dangerous thing to go into. And so really the thing to keep in mind about space is this is the closest earthbound analogy we have for it is, being stuck in a trench somewhere in World War I, between the claustrophobia, the nilophobia, and all of the other benefits, if you will, of going in there. And so we'll learn a lot about that and about how to address that. And I would point out that this, this yesterday, actually, so I was going to say this week, but it was actually yesterday, Chuck Baker defended his PhD, and his PhD took one element of the risks of spaceflight, radiation, and address how we might approach building electromagnetic fields to protect you from being irradiated. If you go to Mars, your odds of getting cancer from going to Mars and back without even standing there is above 50%. So right now that is not feasible. We need to build new systems for that. And that'll be a lot of what you get to do in your projects and everything else in this class. So to end with that, who am I? This is me. I'm Steve Simsky. I worked in NASA Center for the Commercial Development of Space the last 13 years part-time before I went to HP, worked for HP and HP Labs there, and then came on to CSU. Another one of my books that just came out is With My Son on Mistruth in History and Cybersecurity. This has 13 design patterns for how people lie about history, and then talks about how you can use that to build more robust cybersecurity designs. So as you can tell, I'm a real believer in cross-disciplinary types of research and cross-disciplinary types of classes. If you have any questions, I think that pretty much sums it up. This is just my philosophy if you're interested, and I'll hand it back to whoever is it Jim taking care of this in the room, I guess?
Andre is. But,
Andre
yeah,
is. Okay, go ahead. I'll hand it back to you, Andre.
Open it up for questions. There's a lot of different courses, a lot going on. So feel free to fire a question if you got one on any of those for Dr. Simsky. And if not,
you're also always welcome to email me if any of you are interested. So absolutely.
All professors available. You can find the emails if you don't already have them. Send us questions, comments, suggestions. Andre, back to you.
Okay, great. Thanks for that, Dr. Simsky. So we want to open it up to any discussions that you guys in the room might have. So we just want to open it up for any questions, general questions.
Yeah, anything INCOSE, RAMS, student related. Yes, it's time for anybody online in classroom, jump in.
I have a quick comment that when I see the range of classes we're offering, I think it's fantastic and very practice oriented. And I really appreciate that, our students can actually learn some trade or craft, whether it's on a space system or patents or human factors, cybersecurity, all that. It's just fun. It's just phenomenal. Yeah.
It's a lot different than when we started, huh, Cameron?
Yeah. I mean, there was only like 1 or 2 classes. I think the 501, and there was maybe 532 or something. But this is I didn't quite realize the expanse of things that we have at the moment, and that it's not. What I really like is that it's really professionally oriented and cross-disciplinary, and I just wish I was younger again and I would go through this school.
We just got one more chart, Andre.
Yeah, so we wanted to talk to you guys about joining INCOSE and INCOSE RAMS. So you can join INCOSE's website. You get a free account. You can go on to get an associate of a CAB membership. So Colorado State University is a CAB associate of INCOSE, and that allows you to register as a CAB associate of a CAB, right? And that will give you some limited access to the INCOSE organization. So if you are not yet a member of INCOSE, this is a very nice way to get started, right? You can also get registered as a student, or you can have full membership. So CAB and student type memberships are something that will be available to you right now. If you also want to be informed about what the INCOSE RAMS Student Division is up to, you can just reach out to us and we'll add you to the teams. And you'll have access to all the resources there, and you'll get notified of what we're doing. Oh.
Yeah, the other thing I think we had was just
Yeah.
requesting help, right, as part of the INCOSE RAMS. Yeah, just we need students that are, or it's an opportunity for students to give back a little bit, help set up events, some projects we'd like to do. We've got to do some annual reporting, the volunteers, elections. We just got lots of stuff to do, and it's a great way to get to meet more of the students and get to know INCOSE. And as the advisor of the student division, I'm working with INCOSE to try to get more resources for students who are in the leadership roles. So we're looking for people to get a little more active here and help us out. It's great for Andre. I mean, you can see he's in Trinidad Tobago. He's a long way off, and he's helping out. So anybody here on campus, anybody online, we could use the help.
Okay. And there's the elections.
Yep. So I'll jump in on this, Andre. Coming up this fall, we're going to be having elections for cabinet members for INCOSE RAMS. Just real quick, hi, my name's Chris. I'm the president. Andre, we have Ade, and we have Sean right now. Generally positions of president, vice president, treasurer, secretary, not totally strict. With those roles, there's a bit fluid stuff happening there. People are moving back and forth, helping each other out as necessary. Also looking to opportunities for other positions that we may want to open up or take on other responsibilities. But if anybody is interested in joining INCOSE RAMS, helping push this group in a direction to be a tool for the department, to be a tool for the students, we absolutely welcome your input. We'll be dropping a QR code in one of the upcoming meetings. Probably we'll actually have it over a couple meetings. And in that, once you follow that QR code, that link will take you to a form just to give us some information about yourself, why you're interested, and so on. If you have any questions about INCOSE RAMS leadership, please feel free to reach out to myself, Dr. Adams, Andre, Ade, or Sean. I will put my email in the chat if anybody would like further information.
Great, thanks for that, Chris. So that brings us to the end of our event. I'd like to thank everyone for coming out. I'd also like to thank especially the professors for giving us those great presentations on their upcoming courses. So thanks, everyone.
And yeah, have a great weekend. Great semester. Thanks, everyone.
Thank you.
Dr. Adam, should I stop the recording?